By the end of this lesson, the learner will be able to select the appropriate cooking vessel and procedure, differentiate between the 3 different styles of egg cookery in the shell, give examples of factors that can determine the effectiveness and reduce risk of carryover cooking, and summarize the functional properties of the proteins of an egg. Eggs are one of the most versatile and nutritious foods on earth, and they lend themselves to a large variety of cooking methods and combinations with other ingredients. Furthermore, eggs have the ability to bind other liquids and to form light, delicate foams. Some common uses for eggs, above and beyond standard egg cookery, such as poaching, boiling, and frying, are custards, foams and meringues, cakes and soufflés. The word boiling, although commonly used, does not correctly explain the technique. Simmering is more accurate. Boiling water is turbulent enough to smash the eggs into each other and the pan walls, cracking the shells and allowing the albumin to leak out. 2 things to keep track of are the cooking time and the water, which should be short of the boiling point. Altitude also plays a role here, as water boils at lower temperatures the higher we go. Cook the eggs in a sufficient amount of water to completely submerge them. It is common to have the water already at a simmer. Do not allow the water to boil rapidly. Lower the eggs into the water carefully so as not to break the shell. The water should return to a simmer quickly, then start the timing. 3 minutes for œuf à la coque, 6 minutes for œuf mollet, and 9 to 10 minutes for œuf dur. Cooling hard-boiled eggs immediately after cooking will help to prevent a green ring from forming around the yolk. The green ring is the result of an iron and sulfur reaction in the egg yolk, and overcooking is to blame. The way to minimize this discoloration is to minimize the amount of hydrogen sulfide which reaches the yolk. First, cook the eggs only as long as necessary, then plunge them immediately into cold water to lower the pressure of the gas in the outer regions of the white. Since cool gas exerts less pressure than hot gas, the hydrogen sulfide diffuses away from the yolk. Peeling the eggs right away will also help to pull the gas away from the yolk. Eggs can have tiny hairline fractures which will split further during cooking. To test for these fractures, tap 2 eggs together. A clear, strong sound will indicate they are okay. Quick changes in temperature can also cause eggs to crack. To prevent this, transfer eggs from the fridge into lukewarm water before cooking them. Coagulation is defined as a change in the structure of a protein, from a liquid form to a solid form or a thicker liquid. Separated white of egg coagulates at 62 degrees and the yolk a bit higher. These temperatures are raised when eggs are mixed with liquids or with other ingredients such as sugar. Coagulation and thickening of an egg, milk and sugar mixture, as in a custard, will take place between 80 degrees and 85 degrees Celsius, and it will start to curdle between 88 and 90 degrees Celsius. Egg proteins change when you heat them, beat them, or mix them with other ingredients. Understanding these changes can help you to understand the roles that eggs play in cooking. Proteins are made up of long chains of amino acids. The proteins in an egg white are globular proteins, which means that the long protein molecule is twisted and folded and curled up into a more or less spherical shape. A variety of weak chemical bonds keep the protein curled up tight as it drifts placidly in the water that surrounds it. In cooking eggs, it is important to not surpass the temperature thresholds. Custards are a great example of this, and just as one must take care when making omelets and scrambled eggs, pulling the pan away from the heat, for example, to avoid carryover cooking, one must adhere to the proper temperatures for best results. Always use a low oven temperature and a water bath when cooking custards, as this will ensure their slow and even setting. Basically, the chemical reactions speed up as the temperature rises. Egg proteins will coagulate many times faster at 88 degrees Celsius than at 82 degrees Celsius. Using a water bath slows the transmission of heat from the oven to the eggs. And let us not forget that the custard will continue to cook with the heat it retains even after removal from the water bath. So for best results, cool them down quickly in a cold water bath. The traditional method for testing their doneness is a skewer. It should come out clean and dry. Since the proteins have bonded to each other, they are less likely to stick to anything else. Egg yolks coagulate between 80 degrees and 85 degrees Celsius with sugar, but without, the temperature of the coagulation of the yolk is between 63 and 65 degrees Celsius. Egg yolks are, of course, also used as thickening agents. When beaten into hot milk and brought to a temperature of no more than 80 degrees Celsius, they form the base for ice cream mixtures and cream fillings. When mixed with heavy cream, they become what is known as a liaison, which is then blended with a small part of hot soup or sauce to temper the mixture and then combined with the rest to thicken. The finished product should not be kept in a boiling hot water bath, as the temperature could go above 83 degrees Celsius and the egg yolks would curdle. Foods which have been thickened with a liaison should be used as quickly as possible, as they cannot be reheated. Based on the information presented here, explain 5 different ways in which eggs are used in your operation. Cool your eggs down as quickly as possible after cooking and see the difference.